Hi, an update about circuit. I have a few points written down that I want to discuss. Different toroid coils, LED identification, amp draw explanation, crock lead removal effect, measuring amp draw, history with other resistors, questions about capacitance or of the tuning LED, and different ways to measure the amp draw. So let's start with the first point. Right now I have the same toroid coil there as I had before. I have here two different ones, or different. The ferrite is the same, but the windings are different. This one has 12 turns, this one has 10 turns, and they are basically also working, but it will have some effect on the tuning. And let's see if we can demonstrate that. I just remove the 20 turns toroid coil, and I'll put in the let's see if I can do that. See, also working, not as bright, I have to say, and the amp draw is 100 milliamps, and probably I can tune it to less. Amp draws, let's see where we get. The strange thing is that I'm operating on the gain of on the base of the transistor, and right now I'm opening the gain instead of closing. You would expect that closing the gain would allow less current to go through the transistors. But there is some sweet point where the amp draw is optimum, and that's not always if you close the base of the transistor as much as possible. So just to demonstrate, if I close it completely, this is the amp draw. I don't know if you can read that, it's daylight right now, it's 24. If I now open, so I let more amp going into the base, then the amp draw drops. And you can tune it. Okay, that's a nice effect. So with this toroid coil it also works a little less effective, I might say, but it works. So let's put the other one back. Oh, I can showing the other one with a few more turns is not really much of an interest for everybody. You can try it yourself if you want to replicate this. Let's see if I can get this one in. This. Okay. No, something is not really right. Oh, there it goes. Also here again, it's easier to tune the bigger one. Anyway, at the moment we have 1 or 2, 10 or 20 milliamps, and that's because I didn't tune it well. Okay, the next point, LED identification. Last time I mentioned that these LEDs are from Nichia, and they both are, but this one is a 110 series, and 110 actually means with Nichia there are, I hope you are able to show this, I don't think so, but in this fried egg type of thing there are 110 small LEDs compact in this area, compacted in this area, and that's why it's a 110 series. For the other one, it's basically the same thing, but there are 60, and they have different types, and they are a little bit difficult to get. I don't know exactly why, but this one is different than the other. So this is a 60. This has 60 dies in the LED. So basically, it's a little plate with 60 small LEDs in it. and it's rated 33 volt. That's also important. You have more types. I have here another one, for instance. It looks the same, exactly the same, but it is different. And the type, I'll show you. Let's see if I can make that visible. So I have here the numbers. That's the number, type number written on the LED itself. So if ever somebody's interested in it, oh, okay, not focusing anymore. This is it. Right. Let's get back to the about the M draw. I got some questions about how accurate the M draw on the gauge is there, and I agree that I had some doubts for myself too. After some more experimenting, I'm getting more and more convinced that this is actually the correct data. And the reason for that is that the suggestions were made that the tower is radiating a lot of energy, and the power supply could pick that up and shows wrong readings. But the strange thing is that I can do several things with the whole circuit, and it doesn't change anything on the operation. I still get the plasma, and but I can change the amp draw by tuning it. So basically I really don't believe that that this tower is having a lot of effect on the power supply. I don't say it's impossible, but at this moment I don't have any good ways to measure it. I have here a little 1 amp resistor. If I put it in parallel with in the circuit and measure the voltage, it doesn't work at all. So if I put this one in line with the minus and measure it with my gauge, at the moment I put the leads on the resistor, the amp draw jumps up to 300 milliamps. So it's really sensitive, and I don't have a really good means to measure this other than with the gauge on the power supply. Okay, the next thing is crock lead removal effect. I have, like I mentioned before, I have a crock lead here. I touch it and immediately stops the whole operation, and the amp drawer goes crazy. I just put, let's try to get it running again. Oh, there it goes, slowly. Oh, come on, baby. Okay, let's see if I can get it to where I want. Okay, I open the gate of the transistor, and then draw drops again, not to 0, but anyway, just to I just want to show the effect. It's okay, like this. Okay, we have a light burning nicely again, and 0 amp, so less than 10 milliamps. So the crock lead. So we have here the crock lead. It's just hanging loose. It's not connected to anything. It's only I have here the paper and transparent tape over it, and I just clipped it on the edge. If the amp draw is now 0. If I remove this one, the amp draw goes up significantly. So if I put it back, it probably will drop back to 0. Yeah, like I said. So this is a really strange, and it's a very important component. Don't ask me why exactly and what is really happening, but it is. That was measuring M draw. History with other transistors. When I started off with this type of circuit, I tried a lot of different things. Like I said before, I started off with one transistor first. I did that with, I have several types, the 2N2222, MPS A06 or the MPS A, I think it was 42. There are several others. The my meter is showing that it's doing nothing. It's running on 1.277 megahertz. It's not connected to anything. It's just picking up the radiation. I'll put it up because it just want to warn me about the battery usage. Okay. Again, I have tried some other transistors, and I believe the critical thing is that the emitter cutoff amp has to be very low. So it has to start with really low amps. If you take a transistor that will start at let's say 10 milliamps, it won't work. So this is the reason that the BD139 works so well. It has a very low starting point, and that the same goes for the NPN 2N2222 and for the MPS A06 and a few others. And that's the reason why this works, and that's also one of the reasons I think that this amp draw is accurate. And because if you could put some power transistors there which were starting at a higher level of amps, this doesn't make any sense. So this justifies the theory that that this amp draw is correct. Anyway, no, I think I have covered a lot. Maybe it's nice to show. This is a LED from LED engine, very high power. I believe it's 80 watt or something. They use it to light up. It's for to light up stages for concerts, etc. It's a very high power LED. It also works. You can put it in between, so the load is not really important. Bridge lux RS, also 3000 lumen, I guess. Crappy Chinese LED board with SMD LEDs mounted on them. There are several others. Anyway, so the update so far. If you have any comments or suggestions, please let me know. Thank you for watching.